Hey guys, today I'm going to do notes on trophic levels, which we're still in Unit 1, and this has to deal with food webs. So this is continuing with our information that you've already learned about food webs and food chains. Okay, so food webs and food chains. So trophic levels is an extension of that. So trophic levels, they are nourishment levels in a food chain. Nourishment levels in a food chain. What that means is, we have our producers, we have our consumers. It's basically what level they are at. When we mean nourishment, we mean them getting energy from the food that they're eating below them. So our producers are our autotrophs. Remember, those are usually plants. And they're going to be first level. First level. Producers are always at the first level. These are our plants. They make food themselves. So auto means self. Troph means food. They make food themselves. Plants are usually the biggest example of this, and they make food through the process of photosynthesis. All right. Our next level is going to be a primary consumer. And actually, every level after first will be consumer. So we've got consumer, consumer, consumer. So the first level is going to be a primary consumer. Primary consumer. So that means they are the first consumer, and they're going to eat what's directly below them. So that's herbivores because they eat plants. Okay? Secondary consumers are usually carnivores because they're going to eat what's right below them, which are herbivores. So a carnivore is something that eats only animals. An herbivore is something that eats only plants. So plant eater. This is an animal eater. Next level, tertiary. So that still just means carnivore. So it's a carnivore that eats other carnivores. So each one of these consumers, remember, these are all called heterotrophs. Heterotroph. So let me delete this and talk about that. So remember, all consumers are called heterotrophs. Heterotroph. So if they're not autotrophic, then they are heterotrophic because they can't make food themselves, so they have to get it by eating something else. So either they're going to eat plants, or either they're going to eat plants and animals, or just animals. So that's a heterotroph. So omnivores may be listed at different trophic levels. So for example, right here we have a little depiction that shows kind of what we've been talking about so far. We've got a little looks like a kangaroo rat. So that's an herbivore. And then you have a snake that eats that herbivore. So this would be a carnivore. And then you have another carnivore, another consumer that eats the snake. So let me show that a little bit bigger. Move myself. So we have a little kangaroo rat, which eats just plants. So this would be our first, or our primary consumer. Okay, and they are an herbivore. They get eaten by a snake, which is also a consumer. And they're the next level, so they're a secondary consumer. And then if the snake gets eaten by something else, then they are going to be the third. Fancy word for that is tertiary consumer, so the third one. So this is an herbivore because it just eats plants, our little kangaroo rat, so you can imagine plants are right here. And then we have a carnivore, and then you have even another carnivore. Okay? So moving on. So this is another way that we can show a food chain, and this is going to be a little bit more specific, a little bit more detailed. This shows how energy goes through each level of our food chain. So here are these words again, our primary producer. So this shows an ocean food chain. It starts with the sun's energy, Starts with the primary producers, which is phytoplankton and seaweed. So these are our plants. And then our primary consumer. So we have the second trophic level here, the second trophic level, but has our primary consumers because they eat our zooplankton, our cockles, these little shells, they eat what is below them. So our herbivorous consumers, that's our first level. They eat what is below them. The next one would be our carnivorous consumers. They're going to eat what's below them. So things like fish, jellyfish, crustaceans, those are animals that are going to eat herbivores. So they are consumers. They're our first level carnivorous consumers. And then we go on and so forth until you get to your very top carnivore, something like a shark or a dolphin or an albatross. So this entire thing is called an energy pyramid. Oops. Energy pyramid. Because it shows the amount of energy that is available at each level of a food chain. Okay, there's tons of energy available down here. That's why it's the base. So producers have the most amount of energy, and then all the way up here at the top, your top carnivores are going to have the smallest amount of energy, the smallest amount here. This is called an energy pyramid. It shows the distribution of energy among trophic levels. Distribution of energy among trophic levels. And we have something called the 10% rule. It's very important that you know that and you remember that. The 10% rule, 10% rule. So what this means is there's only 10% of energy that's transferred from one trophic level to the next. So it's transferred from one trophic level to the next. 10% is transferred. The other 90%, right, 90 plus 10 equals 100. So the other 90% is lost out of the food chain into the atmosphere as heat. If you think about like every time that we eat something, our body has to go through, we have to grow, we have to repair, we have to keep ourselves warm. So, everything that we eat, like 90% of it leaves our system and leaves the food chain that we're a part of and goes out into the atmosphere as heat, as the heat that we give off. Only 10% is actually remains in our bodies and as matter and stays like that. So if we were to look here at this energy pyramid we were just looking at and did the 10% rule, let's use some numbers here. So, the primary producers down here, they take up the sun's energy, and you can actually apply the 10% rule to the primary producers. As in, every time that they go through photosynthesis, they are only capturing in their leaves, in if we have grass, in little bits of seaweed, phytoplankton, so little plankton that, algae, things like that, within their cells, they can only capture 10% of the sun's energy. So the sun is just a big ball of energy. It's the star in our, solar system, just spewing out energy in the form of light. Phytoplankton and producers, plants, these things can only obtain 10% of that sunshine that's coming down at them. All right, so joules is that is the unit for energy. So let's say we have 1,000 joules of energy down here at this primary producer level, 1,000 joules. Okay, that's how much is in their leaves and things like that. That's how much energy you can access. So if that's how much is there, whenever our herbivorous consumers are eating on there, they're only going to actually get 10% of that. So 10% of 1,000 is 100 joules. So if only 10% goes up, that means how much was lost as heat or energy? That means 900 was lost as heat and energy. And I'm going to switch these to the other side because we have heat and energy lost here. So let me delete that. So we have 1,000 joules here. 100 joules goes up, that's 10%. And what leaves is 900. right? Because 900 plus 100 is 1,000. So what left this level was 900 joules. Okay, so moving on, our carnivorous consumers up here, they are going to eat what's below them. There's only 100 joules left, so whenever they eat, they're only going to get 10% of that, which is 1 joule. And what left at that level was 90. I'm sorry, that's 10. Was 90 joules. Okay, so you can just keep going on and on and on. They're only going to get 1 joule, and then what leaves is 9. They're only going to get 0.1 joules. What leaves is 0.9. And then last but not least, very top up here, not a whole lot, 0.01 joules. And what left over here is 0.09 joules. So this shows another energy pyramid with different trophic levels, but just more generally, so there aren't any examples here. So let's go over some examples. So our primary producer level, this is the level that's going to have the most amount of available energy. And primary producers are going to be things like plants. So autotrophs. Okay. This also shows that the most like biomass, so the most amount of organisms are going to be located at the bottom as well. And as you go up, you're going to have less and less biomass. So that means like how much of that organism. So it's like literally number of organisms. So it's directly related to the percent of energy available, and also the biomass, so the number of organisms. So you know, like in a normal, like in a I don't know, a grassland or farmland ecosystem, there are going to be a whole lot more plants than there are first level consumers, which would be something like a cow. So there's going to be a whole lot more grass than there is a cow, and that's because there needs to be more of the energy level below it. There needs to be more plants in order to support that many cows. All right, so they would be the first level consumer. They would be the first level consumer of, and it's because they eat what is below it. So if we had 100% of energy here and a whole lot of organisms, the next level is going to have a cow or cows, and they're only going to get 10%. So what eats a cow? Well, humans do. So maybe humans would be here at this example. And then what eats humans? Oh Lord, I don't know. I wouldn't want to know. Okay, but our third level consumer would be something that eats that. All right, so when we as humans, or our second level consumer, if we eat a cow, we are getting 10% of the beef that we are eating, and 90% of it is going to leave as heat. So this shows same thing, just different picture. All right, your producers are going to be the most plentiful organisms down here. And then you have a primary consumer, something that eats the producers. You have a secondary consumer, something that eats the primary consumer. And then you have a tertiary, something that eats what's below it as well. At each level, you lose heat, you lose 90% of it, and only 10% goes up. All right, so our flow of energy is always up the energy pyramid. So remember, this is called an energy pyramid. So the flow of energy always goes up. Producers are going to be at the bottom, so plants. This also shows the you're going to have the greater number of organisms the further down you are. That's also called biomass. So the more organisms are going to be located down here, the less are going to be up here. So up here, the smaller number of organisms you're going to have are you know, your top apex predators, so sharks or a lion or hawks, things like that. If we go back to this example, you have your top carnivores, okay? The reason that there aren't as many dolphins as there are seaweed or phytoplankton or algae is because there isn't as much energy to support that many organisms, okay? So that's why you're always going to have more primary producers and primary consumers than you will tertiary or quaternary consumers, because there's more energy available for those organisms to exist. So keep that in mind. This is another way that we like to show, and this is something similar you might have seen in your book. So in your book, remember this is chapter 4, I think it's 4.2. These are pages, look, 118 through 121, all right? Or it's chapter 4.2, where you guys should have done the reading already. So this shows it more drastically, and this shows, you know, the number of organisms you're going to have and the amount of energy. So remember I had said that joules was our energy unit, and that's spelled like this, not the other type of joule. This is energy joules. So if we had sunlight, so remember sunlight, if we had 1,000,000 joules of sunlight, then plants are only going to get 10% of that. All right, the rest of it is not used. The rest of it is gone from the, they're not able to keep it. It leaves as heat. So we have primary producers, plants. And then you have your grasshopper. Grasshoppers are going to eat the plants, and when they do that, they only get 10% of the amount available, and then the rest leaves. So if they're only going to get 10%, grasshoppers only get 1,000, then how much left in the form of heat? 90% left in the form of heat. So then that would be 9,000 joules left in the form of heat. Okay, so if only 10% goes up, how do I get rid of that? Then from 1,000 to 100, then 90% leaves, and that would be 900 joules. For our secondary one, like our little mouse, kangaroo rat, something like that. And it's going to eat the grasshopper. And then next we have a snake, tertiary consumer. The snake eats kangaroo rats, and so they're only going to get 10%, 90 left. All right, so make sure you know that 10% goes to the next level, 90% leaves in the form of heat. Okay, so that concludes the notes for today. I have a scenario where I would like for you to think about if you were on an island with a small group of people, you were stranded, and all you had were 500 bushels of wheat and 1 cow. So basically you had a bunch of wheat and then you had 1 cow. What would you do to survive for the greatest length of time with a small group of people? Let's say you had 10 people, including yourself, on the island, and you only had 500 bushels of wheat and 1 cow. Come up with a plan. I want you to write down your plan and your assignment of what you would do to survive for the greatest length of time.